Hi everyone, proud to be here today. I'm here with ALH Systems in partnership with SGN. As you can tell, I'm not Scottish, I'm Bristolian, but I'm privileged enough to be in it's in partnership with Scotland, SGN. So what I'm going to talk to you about today? I'm going to talk to you about several things, myself obviously, why am I here, all the way through to the project itself and all the tasks at hand. So let's jump into, well essentially this is the R&D team. You can see the star there, that's myself. Proud to say, I've only been in ALH System for 2 years, and I'm proud to say I've gone from a temp all the way through up to lead design engineer. So I'm pretty proud to say I've done a good job there. A quote I want to say from the start: every problem has a solution. Down to the chairs, to the phones you've got in your hands. People take this for granted, but each and every time there's always been a need for something, and it's where people like myself naturally gravitate to get a solution. Bit of educational background and a bit of industry background. Excuse me, I've got a Bachelor's of Science in Product Design Innovation. Been working in industry all the way from stair lift design, additive manufacture, FDM 3D printing, through to valve design, which leads me up to ALH Systems. So only 2 years ALH Systems, not a lot of time at all. Been a very steep but a very enjoyable learning curve. Prior to that, I didn't even know what this was. As we know, it's a gas meter. It reminds me of my mother. She used to ask me, Scott, what's the number on that? So I'd reach up, little kid trying to look up for her. But just to give you a grounding of prior to this experience, this is as much as I know. But a bit of personal about me, just so you can get to just me as a person, all the way through from educational. You can see 2 pictures there. There's a vintage model car. I love collecting model cars, brings back good family memories, and my family on the other side. These 2 things, just so you can get a gist of what I love to do in and outside of work. So the task at hand. SGN approached me, said, Scott, we've got a problem, can you come up with a solution? It was roughly a TRL level 1 to 2. Essentially, it was just an idea. So my job is to research, conceptualize, develop, and test. So what is the actual problem? You can see there are guys on the screen. You've got an excavation on site, and what that is that is a perfect example of an ALH System PE twin bag set. And what that is, if you can picture in your mind's eye, going down the road, and you'll see, I don't know, driving down the road in the car, and to your left or right, there'll be a field. 9 times out of 10, what that will be, that'll be a housing estate or an industrial estate at some point. So at some point, they need to branch off, like in a PE network, off into that site. So they said, Scott, is there any possible way we can get around and branch off utilizing different methodologies? Because there's a few problems with that. There's a lot of components. You see on the screen now, you've got many things. You've got a small schematic there. Lots and lots of things going on. Size of the excavation. In terms of excavation environmentally, that's costing a lot of money, a lot of time, a lot of effort. So community buy-in environmental is massive. As soon as people are like on your house and say, oh, see a big excavation, oh no, how long is that going to take? How much mess is that going to provide? So SGN said to me, Scott, is there any way we can get around this? Just give you another example again, old methodology, and you've got a new methodology. What they want to do, they want to produce this. What this is getting rid of all of that previous equipment and just having this simple setup. What this is, you've got your host main, then you've got a branch saddle, electric fuse coupling, and a PE ball valve. And what they want to do, if you can see where the green cross is, what they want to do, they essentially want to attach a drill. Is there any way we can attach a drill to this to enable a live drill, essentially, getting rid of all of this flow-stopping equipment? A few specifications around that, though. Essentially, it has to be full concentric drilling. What they want is essentially a PE ball valve, a plastic valve. And when you've got a plastic valve, it's susceptible to damage. So it needs to be a non-invasive, a simple, essentially like magic. You can put it on, do the job, and leave it like it'd never been done. Concentric drilling, there's 4 ball valves I need to attack. Got a PE 90, 125, 180, and a 250. What this essentially is, unless you guys don't know, PE 90 ball valves this big, all the way up to a 250, tripling in weight. So there are several things I need to attack on that. Some other inputs from field engineers, I find them invaluable. Simple things like single man lifting. In terms of environmental impacts in the van, or well, even from there, in terms of maximum operating pressures, 2 bar. 2 bar being the generic go-to for any standard jobs they do. Easy to assemble. Many things have come back to us in ALH Systems and think, how have you damaged that or whatever? When you look at how the methodologies of things been designed previously, you can really understand, oh, it wasn't quite tailored to what you need. So my job as MPD, new product development, is to create a better solution. Desired modular you'll see on there. What essentially is, you've got the PE90, 125, 180, 250. Is there any way we can kind of cross-pollinate components and join things together? And then what that will do, limit shelf stock. On the van, you've only got one box instead of 4 boxes for 4 drills. Could we make a smarter way of designing things? So my initial initiatives, 2 bar, they say. Is there any way I can expand any further? So I'm proud to say I've pushed it forward now to 7 bar. So we've moved from 2 bar to 7 bar intermediate pressures. That expands the envelope massively in terms of going forward with things. You've got additive manufacture. Prior to my experience in ALH systems, which I'm proud to have implemented into ALH systems, we use 3D printers. With 3D printers, we create things like, it's called bridge tooling. And what bridge tooling is we'll design something one day, overnight we'll print it, or say it takes 2 days, then after 2 days they'll try it on site. It won't last forever, but the point is you get a really good understanding and a good grounding from a design perspective. So that's something I was really proud to implement. Weight saving. Previous guys in the audience and girls in the audience, you'll see metallics, I don't know, mild steel, cast this, cast that. Is there any way we can make things smarter? So, I don't know, 5,000, 6,000 series aluminium. Just making simple structural changes that goes a long way in terms of environmental impacts, weight impacts, anthropometric ergonomic impacts for how people hold things. It makes a lot smarter way of designing things. You can see in the middle there's the cutter. I've joined up a partnership for a fantastic cutter, which means on site you can do, essentially you've got a 4-bore drill, which holds the coupon, holds the swarf, and holds the ribbon as well. That's the key thing on site, you don't want to be dropping anything into the house main. So I'm really happy to say that we've accomplished that. Well, I've accomplished that. Concept stage kicks off. So what we've got there, we've got what I like to call solution 1, S1. You can see there, it's got a bulky solution, field engineering impact. It was something like, essentially throughout these you'll see it's been sculpted onto S2. More of a technical solution, but it was, in terms of on-site, it might be a bit cumbersome, very technical. A lot of things going on. Then we've got S3. S3, you can look at it now, and you can see it's much more of appropriate design. Looks more like a drill. So from these 3, it kind of sculpted all its way through, and it was just kind of, to me, that's how you should do it. It's called the PLM system, Product Lifecycle Management. These things need to occur because if you don't do these things, you won't get the right solution. So after that, guys, I'll give you the PEM drill. Personally, I love it, but I would. So just to give you a little bit of background solution on it, what we've got here, we've got the clamshell design. If you remember I mentioned to you the non-evasive contact. Essentially what that is, I said, you're attaching something on, but like it never happened. So what we've got the clamshell. You'll see it here, guys. What you're essentially doing, you're going around it. So you're wrapping around the P ball valve itself. But from there, you're using push pins. You've got a pin there and a pin there. So you're locking it in place. Everything's tied in. The last thing what I'd be doing is dropping nuts and bolts on site. Down the dirty hole. I know for a fact field engineers don't like it. The actual handle itself, drive-wise, I think I mentioned it before. What you've got essentially, on site you'll use an air ratchet. Well, but with an air ratchet, you'll have, you'll use it, but if it breaks down, you need to do it manually. So what we've got an air ratchet capability, but at the same time, you can utilize hand stuff as well. Pressure containment module, located here. Essentially, this is a very generic image, and what this image is showing you is a simple seal layup of rotary lip seals made of zircon materials and simple elastomeric face seals. Very simple solutions, because there's only one way the pressure can release. Besides taking out the actual PE network itself, it can only come out one way. Simple design. Throughout the presentation, I'll talk about it quite a lot. What essentially you can do, all you simply do is slide it all on one way. It's got simple nut structure, and it literally is that simple. You can assemble, do the job, and finish the job in under half an hour. Comparison to setting all that previous equipment up, I think you'd agree with me, it's pretty good. So how does the PEM drill work? As I mentioned, the clamshell, you simply attach the clamshell, all one-way assembly. Nice and simple. Pressure test, step number 2. This is a generic thing on site. We all do this on site. Essentially, this is not only making the drill safe, but this is making sure the network's safe. Because if you haven't got a safe network, you don't want the operatives working on it. Step 3 and step 4. What essentially you're doing there, the drill's in its finished state at the second. What you've got, step 3, you'll simply open the ball valve. You'll do the drill operation. That's the cutter this side. Careful, guys, if you're around it later on. And then step 4, you'll retract it straight out. Utilising this, close the ball valve off. You'll purge the remaining gas out, utilising this section here, and you'll detach it the exact opposite way you put it on. Just take the nuts off, slide everything off, undo the clamshell, take it away. I thought I'd do a design check sheet, make sure I hit all the targets of the client. A live drill, you can see. We can attach it to a live drill, non-evasive contact, full concentric drilling each and every time. Simple design. We're going to go on to it again. I really want guys to understand it's a very simple methodology. Please come and find me after it, and I will show you. I've put a trophy next to this one, reduction in excavation size. Perhaps the biggest part of the whole lot. If you go into the excavation there, let me just go back to the image. The old methodology and the new methodology. What you've got there, all this equipment, but you'll notice it's very wide. You can see the crosshair in the middle. What you're doing, you're taking that center section out, and you want to go perpendicular to that. You don't want to go widthways. This is the solution going forward. Much better solution. The red area, it's not required anymore. If you've got a generic 5 meter long excavation, 1 meter wide, and it's roughly 1 meter cubed, you're roughly saving, from an operative's cost, £550 a cubic meter. So that's £2,200 per job just for the excavation. You can see the green area is what you require. And you're going a direction of sight. Each and every time you're going the way you need to go. Community buy-in's massive. Environmentally, you're only going on that field. You're not working sideways on the path. You're not going to go across to anyone's houses. Any third-party costs. 75% reduction. That's massive. And I'm really proud to say I've achieved it. So where are we now with the project? We're roughly TRI level 6 to 7. So technical readiness level. Essentially, we're development stages. We're tailoring things through, working our way through. We've got pressure tests kicking off in Kilburney Street very, very soon. Currently, we can work at 4 bar. And with 4 bar, we've already expanded it further. Because 2 to 3, 1.5 times pressure. With 7 bar, we are going to be pressure testing this to, not this one in particular. This one's a PE90. The PE250 will be about this big. That'll be a 10.5 bar pressure test. So taking things forward into the future, what are we going to do now? More attachments, reduce time, more industries. Where can we take it in terms of industries? For the attachments, we've got PE ball valves. Out of the 30-30 program, out of that initiative, can we not attach it to metallic flanges? More industries, I don't know, water, for example, or whatever, recyclable. This is a very interesting one to me because in terms of who knows where we're going to be, and can we utilize the PEM drill skills to go further? Higher pressures. I've already expanded the envelope, guys, and I've gone from 2 bar to 7 bar. Why can't we go further than that? It's simple design solutions, simple techniques. Long-handled tooling. Prior to other projects I've been working on, this is a really interesting opportunity. Can we make things safe for guys on site? If the guys aren't right next to the danger, if you will, it's a much smarter, innovative solution. So I feel that's something I can conquer as well. I want to leave you with a quote. Essentially it says, he who says he can and he who says he can't are both usually right. I believe that I can produce a solution, and I believe us as iGEM can produce a better PE network going forward. So, I've been Scott Rendell, and thanks for listening.
I just go first. Should we go this way this time?
Thanks, Scott, and interesting to hear your background as well. Two questions, I think, related. You focus very much on the product development ergonomic side. What about the link to the technical, in the sense that you mentioned 2 bar to 7 bar?
Yep.
What were the issues there, and how did the pressure containment aspect? How did you link that in to the design work and clear aim to be?
Yeah, sure. No, that's a great question. What I would say is the initial thing what we were doing, myself, is essentially what I would do, FEA. I jumped straight onto the FEA, do your simple calculations, how you're going to work things out. And then from there, it was a simple iterative process. Where do we want to be? The standard pressure vessel is roughly factor of safety 5 to 6, essentially hitting these monetary targets. In terms of factor of safety 4 to 5, fine, hits that. Weight reduction exercises, simple product design exercises.
What about the cost implications of different materials, for example.
Couldn't agree more. What essentially we're doing is, I rehearsed that before I come on. What essentially that is, we've got different methodologies. We've got simple turning exercises. No need for, I don't know, 6-axis milling machines, 5-axis milling machines. A lot of this you can see circular. So because it's circular, what that's actually doing is simply all these jobs go onto one lathe. So essentially you're keeping it on in terms of your turnaround time, you're making it as simple as possible.
Okay, thank you.
So, thanks, Scott. My question is, how many occasions, what percentage of occasions is the technology applicable to the connections? And therefore, what's the overall potential impact?
Okay. If I talk about the initial briefing of when I was spoken to about, essentially you can utilize, so if you picture the scenario I mentioned to you on screen before, where you're going down the road and you've got the actual setup, this essentially targets one aspect of it. So this aspect is, as we know, housing estates are growing. I've bought a new build myself. So at some point, there must have been that scenario. So for me, percentages, I can't give you a percentage, because that wasn't something what was communicated to myself. But I do know, in terms of the feasibility of what's required, you can see through the components, the reduction. It's more the impacts environmentally as well as community buy-in. That was a big thing communicated to me. Can we utilize this technology, essentially the gas main leading off, that will negate any unnecessary mess, if you will.
Scott, could you just give us a bit more information around how you interacted with the customer during this? Because you said you got an existing design brief there, but was there more interaction as you went through? You mentioned at one point interaction with the field as well, but I didn't get all of the detail there. But
Okay, yeah, sure, that's great.
flesh that out a bit.
Yeah, essentially at the very start we had a brief. I went to Glasgow Kilburney Street, spoke to the project sponsor for SGN. Simple schematic of what we required. I went off, and it's a simple stage gate process. Throughout the case, it'd be like, I think it was 12 weeks conceptual stage, when you're seeing, going through to the stage. So it's a simple iterative process. I love to use field engineers because they're close, but they're also close to the site. It makes sense each and every time.
Do you find those field engineers receptive to where you're headed with this?
One thing, some really key things, the simplicity aspect. Not saying they're simple. I'm saying in terms of, I would say it was a case of these are 24mm nuts. That's a 24mm section. All you need is one ratchet spanner. Simple things on site. When you're sat on a desk or whatever, it's a simple oversight you'll do, because you'll think, oh, it looks great on the screen. But until you get a rapport, then you really understand what's going on.
Could I build on Tony and Chris's question, please? What involvement will you have in the future around the deployment of this, the commercial deployment of it?
Okay. In terms of the very initial bit of deployment, I'll be at each and every field trial. Okay. So that will kind of give me more on-site knowledge, if you will. So that will give me a more susceptible. And my boss at the back, Andy Vine, what will happen there? Essentially, there's going to be a crossover period, and then I will be essentially mentored through that stage. So I want to be part of that commercial as well.
You're obviously very positive about this, and you're doing a great job in terms of extolling the virtues of this. What about the challenges? Any particular things that tripped you up along the way?
Many, yeah. Okay, I would say the main thing for myself is dialing it down. Being R&D, you want to make the best of everything. But unfortunately, if you spend too long, you'll be gone forever. So there has to be some point where you kind of go, nope, that's the point, move on. It's my enthusiasm to dial in my enthusiasm. That makes perfect sense what you said. I want to keep going and going and going and going and going. And they're like, no, we're finished now. Good job. Move on.
Thank you.